Hello everyone. Today we're studying a series on building a credit card fraud detection system using machine learning. We will work with a real data set of about 285,000 credit card transactions. The interesting part, only 0.17% of them are fraud. That's less than 500 fraudulent transactions out of 285,000. So the challenge is, how do you find those real fraudulent transactions? Let's build a system to do exactly that. I'm Yan Hong, and in this course, we are building a completely fraud detection system using Python, from exploring the data to creating a working dashboard and API. This is a hands-on practical course. By the end, you will have a real project for your portfolio that demonstrates your machine learning skills. Let me show you what we are working with. We're using the Kaggle credit card fraud dataset. It has 284,807 real transactions. Only 492 are fraudulent transactions. That's 0.17%. We have 30 anonymized features. It contains transaction amounts and timestamps. Here's why this is interesting. If we just predict everything as not fraud, we will be correct 99.83% of the time. But we would catch zero fraud. That's useless. This is the accuracy paradox, and it's what makes fraud detection challenging and perfect for learning advanced machine learning techniques. Here's what we will cover in this series. We will start with data exploration, understanding the patterns in our about 285,000 transactions. Then we will progressively build more sophisticated models, basic models like logistic regression, random forest. For deep learning, neural networks with custom loss functions. Then we move more advanced techniques like ensemble methods, graph neural networks. We will train 15 different models total, reaching 91% F1 score. Finally, we will create an interactive dashboard, compare all model performances, visualize the data and predictions, test live predictions on sample transactions. Each video builds on the previous one, going from fundamentals to research level techniques. Let me show you what the final system looks like. This is the dashboard we will build. You can see we have trained 15 different models, from basic logistic regression all the way to advanced graph neural networks. Our best performing model is a hybrid ensemble achieving 91% F1 score. Here is the data exploration page. You can see the extreme class imbalance, 284,807 transactions with only 492 fraudulent ones. Those visualizations show how fraudulent transactions have different patterns. This is what the model learns to recognize. Feature engineering. This page shows different transformation techniques, like how we transfer time series features, statistic features. Machine learning code demo. In this page, you basically show interactive machine learning code. You can select different code to demo, like different parts of your machine learning life cycles. Model performance page. On this page, we show 15 different models performance. So you can visualize how the model forms, like based on their F1 score, AUC stuff. This page will shows live fraud detections and business impact analysis. So this will show like business metrics like cost analysis, ROI, financial impact of fraud detections. Deployment guide. That page we will show like a production deployment strategies, API examples, Docker setup. Before we wrap up, here's what you need to follow along. Basic Python knowledge, some familiarity with pandas, basic understanding of machine learning concepts. For tools, you will need Python 3.8 or higher, Jupyter Notebooks or VS Code. The Kaggle credit card fraud dataset, link in the description. That's it. If you can write Python code, you are ready to start. In the next video, we will dive into the data, exploring those 284,807 transactions and understanding what makes fraud different from normal transactions. 3 things to do now. Download the dataset from Kaggle, link below. Subscribe if you want to follow along with the series. Set up your Python environment today. Drop a comment. Are you a beginner or do you have some machine learning experience? I would love to know who's learning with me. See you in the next video where we explore the data.